Hello, everybody. I'm Rob Hirschfeld, CEO and co-founder of RackN, and welcome to our second demo for Cloud Field Day 15. In this case, we're going to be talking about how to scale infrastructure as code across sites and teams with a focus on day two Ansible. So actually looking at how we can build systems and scale by automating Ansible work and also even doing it directly on the machines and bypassing the choke point of running Ansible from a centralized system. To do this, we're going to be reenacting a fictional bank that's called Bank N. I will be playing the role of platform chief and helping onboard our new employee who came over to Bank N from Bank of Cloud. Welcome aboard, Shane.
Thank you. And I'm Shane. I'm a cloud architect. I'm excited to be starting here at Bank N.
So we're excited to have you. So how can I help you? You're trying to use some Ansible?
Yeah, so I did a bunch of Terraform stuff and I got a bunch of machines, but now I want to run some Ansible on them.
Okay.
And so I started with an Ansible template because I have watched some of your videos and I know that I need to put my Ansible into a template.
Excellent.
And so I have this Ansible template here that I created.
You created it? Looks like you borrowed it from somewhere, but that's normal. Everybody borrows Ansible from places. Maybe we should clean this up afterwards. Okay. So this is a pretty straightforward play. It's just a local play. It does all its work on the system.
Not doing much, just a simple test because I want to make sure that the system is working and executing what I need, and then I don't have to troubleshoot Ansible problems.
Okay. So you're trying to make it run. You want to run this play on all the machines in a cluster?
Yes.
Okay.
I want to be able to replace Tower or AWX or something like that. Be able to batch run Ansible.
Cool. Well, let's go ahead and do that. It should be pretty straightforward. Why don't you grab the name of this template, because we're gonna need to add that into the system. That's great. And then, do we already have some clusters running?
Yeah, I have those clusters earlier from the Terraform work that we were doing.
Excellent.
And so I have these two new shiny clusters we created.
Cool. So pick one. Which one do you want to do? I think East is a little bit bigger. Why don't we start with the big cluster?
Okay.
So here we've got a cluster. This makes a lot of sense. Scroll down for me a little bit. So you want to run Ansible, right?
Correct.
So Ansible is just a tool. We have to have a place where Ansible is installed. So the first thing we need to do is actually switch the container that's backing this cluster to something that has the tool we need.
That's these contexts here.
Exactly. And you'll notice we have a whole bunch of different choices to go from. We have a ton of them that we build for other clusters too and put our own special tools in it. Cool. Yeah, switch those both to Ansible. That's the current one and the default one that it'll fall back to when it finishes. So that's great. So now we have Ansible available. And now, next thing we need to do is tell the cluster which Ansible profile to use. So before we actually kick off any Ansible work, we have to tell it to use that template that you had.
Okay,
so
what would you like me to do now?
So I would like you to, do you remember from some of your videos? I want you to add a parameter into the system. So go into, well, let's do it at the cluster level. So there's a subtlety in here where we can add information to the cluster, which is only available to the cluster, to the machine that is the cluster. But if we want something that's shared for all of the systems, then we put it in the cluster's profile. So here, if you go up, this
right. So there was this profile that's dynamically created that manages the cluster state.
Correct. And if we add it here, then all of the machines that are also in the cluster and assigned to the cluster will see any information we add here, which will be handy in the next step. So go ahead and add a parameter here. And it's going to be Ansible. There you go. Playbook Templates is where we have templates that are playbooks. And you'll notice it has a safe default in here, the test playbook.
My playbook?
That's where you do it.
All right. That's easy enough.
Excellent. So now we've told this cluster what Ansible we want to run. Now let's run some Ansible.
Okay. And so we want to either run a specific blueprint that executes that template.
That's all it is.
Okay.
And let's see if you can figure out which one does it.
Well, I'm going to guess it's probably Ansible apply.
That sounds right.
Fabulous. And go ahead and run this.
So let's run it and jump over to the activity page. If you open here, you'll actually see it doing the work. And now it's being run from the cluster. And look, what does that look like to you?
It looks like good old standard Ansible.
Exactly. It's just running it. You can see it's running on all the machines in the cluster and giving you the output that you'd expect from the job log.
That's nice and easy.
That's pretty cool. Now, don't do this.
Okay, why not?
Well, the challenge is that this actually puts a lot of load on the centralized server. So it's doing all the work. It has to have SSH access into all the machines. And if we start getting big clusters like we have in production, this type of work can really bottleneck Digital Rebar from a load perspective.
I saw that at Bank of Cloud. We would have 1,000 machines, and it would take sometimes hours and hours.
The Red Hat people, there are companies that really enjoy when you hit those type of licensing thresholds.
So how do we fix that?
So let me show you how you can actually turn this work into something that runs on all of the machines individually. Because we have the runner, we can just run this in local mode automatically. So if we want to do that, we need to do one additional step.
Okay.
So there is a blueprint that will let us automatically schedule the machine, that Ansible play that you just did on the cluster and ran as an SSH task to run against all of the other systems.
Okay.
Go back into the cluster profile where you are. You're in great. And then let's add in, there's a cluster blueprint command for this. For all blueprint. So when we set this, go ahead. When we set this, and then it'll let you select blueprints and apply all.
So if I do apply all, Ansible apply here, and then the cluster all for blueprint changes its behavior?
Exactly right. You're telling it which blueprint you want to run. Now we have a button that we've assigned where I can define all this on the fly too, but let's do it so it's built into the cluster's behavior. So now if we go over into the activity tab, now you can pick a different blueprint, which is not the Ansible apply. That'll just rerun the same thing. Scroll down a little bit, you'll see a cluster run blueprint for each member.
Okay.
Okay.
You want me to run this one?
And that will run the blueprint, the apply Ansible, on each member of the cluster. Go ahead and do that for me.
Okay, that's exciting. Well, that was fast.
Well, here it's not actually running Ansible, it's just scheduling a bunch of blueprints.
Oh, so it's scheduling those over in the work orders?
Exactly.
So we would see those as work orders over here. And sure enough, there are those Ansible applies.
Right.
And there it is currently running.
Well, in this case, it's installing Ansible because Ansible wasn't installed on those systems. And now it's running that exact same, whoops, and it closed it for us. That exact same playbook.
And all of those have finished up.
Right. So now we've turned our sequential operation where I had to do that work on the server into a scalable distributed operation where I'm able to do that work across my whole fleet.
So the same Ansible apply let us do a cluster approach as a remote action, as well as a local playbook approach on each of the individual machines, much faster.
Exactly.
You basically parallelized what was previously a run in order through this iterative scope of machines.
Correct.
So, and on the RackN side of this, are you maintaining a separate cluster of workers that are either containers on some kind of nodes? We've still got the SSH problem, like with the number of ports that are going to be opened and resource limitations.
So can you go over to the machines, please? And if I need to, I'll bring back the architecture picture, but let's see if I can just answer. Every machine has a runner on it. They're optional. You do not have to have runners on systems, but the runners have a WebSocket subscription back to Digital Rebar. So they're very lightweight, but they're running on the machine waiting for a command. And so when we issue them a work order, right, or a workflow, they'll start doing that execution, and there's no load on the Digital Rebar server.
Okay.
Now you can create pools like resource brokers or essentially pools of workers waiting to do work.
Yep.
And those can be on the system or as you scale up. Like if you like the pattern of SSHing into machines, you can build a worker pool and then run those as in worker pools.
Okay, so these are still RackN agents that are basically persistently connected back to the Rebar server, but the brokers could still scale out as their own sets of containers to do the work.
That's exactly right. And the benefit here is that since we're not connecting in, we're an agent, right? It's the security zones are directionally attractive from that perspective. One of the things that we did for this, you want to talk about the button?
Trigger button.
The trigger button?
Yeah, I saw this interesting thing up here, trigger buttons. What do these do?
So I get tired of jumping back and forth and navigating so much. So RackN allows you to create a trigger event. These are just events that fire from the UX, but the backend catches them, and then we take action. So we built a trigger, that runs this cluster apply on the system. And so if we click that button, it will do that Ansible run right now for us. Sure, go ahead and try it.
So I can click this button and it'll.
The same as that last apply you did, and you'll notice it's queued it and then it ran it. Go ahead and click it again.
What if I go crazy and click it a bunch of times?
Go ahead. Let's see what happens.
Oh, it looks like it's queued up a bunch of them.
So here what's happening is all of the work order system is not just a, you don't have to coordinate it and schedule it. It's a queued system. So I can queue up work that I want done on the system without worrying whether it's ready for the work or not. And what you're doing here is you're literally running that Ansible apply over and over again. Notice the first one hasn't finished because we hadn't installed Ansible yet. So it had to install Ansible. It's going to take a little while and then catch in and go. But this way, as we're managing fleets and fleets of machines, we can take actions against our infrastructure as a predicted result. Remember, blueprints are all infrastructure as code. They're locked, they're repeatable, we can distribute them to all of our sites, and then create simple hooks and things like that that make that go.
I have a quick question.
Yeah.
Imagine a resource creation like in EC2 instance, and after that, Ansible execution after the creation. Are you coordinating the asynchronous creation of the EC2 instance with the run of the Playbook Ansible, for example? I mean, if you create an EC2 instance, the EC2 instance, yeah, if you use the Terraform simple, let's say element, yeah, it's simple. Put the command in AWS, and then AWS has a scheduling that
just goes loops and keeps banging on it until it succeeds. That is a really dangerous ops pattern. We do not do that.
Okay.
What we're able to do, because we're aware when the machines check in and run, is that we can actually watch and wait for check-ins and when things happen. Did you want to add to that? Okay. And that's one of the nice things about having a cluster abstraction is we actually have a place to wait and watch for things to happen. Like when we create a cluster, we didn't point this out, it's literally waiting for the systems to complete their work. And that's a checkbox. So you can say, you know, as soon as Terraform thinks it's done, I have work I need to do and not worry about the machines in that cluster, or it can come back and do it. And there's a subtlety in what we built where it actually built the host ini file when it did the SSH run dynamically based on the machines that are in the cluster. Just like in this case, when we hit that apply, I said, oh, which machines are in this cluster? So now I have a way to organize things. So now if a development team is coming in and saying, I need resources, you can say, well, I'm not going to give you individual servers, I'm going to give you a cluster. And the clusters have cleanup operations built into them. So I can now destroy all the machines in the cluster. Like for my dev environments, there's a nightly sweep and any clusters just get torn down automatically. So I don't have to worry about leaking resources, things like that.
And one of the things actually that Nathan brought up yesterday is the concept of scale to zero. And we often don't have it at a true like prod application perspective, but I see this like fantastic use case of, I mean, it's also a BCP DR use case because your distributed system, you could effectively create what the template of an environment, and then you could just simply go to a new location and deploy it because you can actually scale the concept, scale the actual active work to zero because the definition is there.
So this is part of what we highlighted in the Cloud 13 demo, is that you can actually define, so the security team can define a template and say, I want you to run this template on all my systems, and then distribute that template so it's available. And one thing that's worth pointing out is we're doing day 2 right now. You could take that same Ansible apply action, define the parameter, and then inject it into a pipeline. And then when the machines are provisioned, it's going to happen as part of the normal provisioning. So there's only one set of tasks in automation, and then they get reused.
I assume you still have to scale the WebSocket portion of the server. I mean, they have persistent connections. They use so much memory. You just couldn't take 100,000 machines to one WebSocket.
Scale is definitely an important issue we deal with a lot of our banking customers that are driving towards the hundreds of thousands of physical machines. We do have customers with a single DRP endpoint that are pushing 12,000 machines in a single DRP endpoint. But that's also one of the benefits that we're very easy to deploy endpoints. We don't penalize you from a licensing perspective, cost perspective. Go ahead and bring up 3 or 4 DRP endpoints if you need to. Yeah. It gives you more control points. And then with the multi-site manager, we can manage all of those DRP endpoints through our infrastructure as code. So we get distributed IaC across them.
Yeah.
And you can have a clean CI/CD pipeline workflow, pipeline in this case being that CI/CD construct, where you test in a dev test, QA lab or whatever. You define these policies, these procedures, how these templates and configuration work, and then you can promote them into production, and then it can be pushed down through that multi-site manager to all of your endpoints.
It's much lighter weight than a polling cycle or anything
Oh,
else.
yeah, for sure.
The agents wait where they watch, and if something changes they need to act on, they spring into action. So it's incredibly lightweight from that perspective. We've scale. That is not where our scale challenges become. This concludes our second demo, where we've been showing how to scale Ansible on day 2, talking about some day 1 use cases also. If you would like to try this yourself, it's really straightforward to go in and play and build this type of architecture. Please visit RackN.trial and do it yourself, play with the Digital Rebar instance and start learning.